Welcome to this short Medchemica MCPairs training video. This video follows others that describe how matched molecular pair analysis works, general introductions to the MCPairs tools, and rule design. In particular, this assumes you have previously seen the training videos on submitting a rule design run. In this video, we describe the easiest method to view the results from rule design. At this stage, we will have entered a query molecule, selected a goal, applied filters, and performed the run by clicking Submit. In the history window, we will have seen the run being monitored on the server and completed. The number here indicates the number of compounds suggested by rule design. The most lightweight or rapid method of looking at compounds starts by clicking this blue greater than symbol on the left-hand side. If we have performed multiple runs in rule design, we will have multiple rows in the history window, so to see the results of a run, we click the blue symbol in the row. As you can see, the row has expanded and the product molecules are displayed. The results are paginated, so here we click through the pages using the tabs to work through the results or fast forward to either end. It displays 8 molecules per screen. Hovering over a structure will show a larger depiction. You will have noticed the blue highlight. This is highlighting the atoms in the compound that match the query molecule. There are instances where rule design has not highlighted the compound at all. This is because sometimes it is not possible to do the computation quickly, so it is skipped to not delay the displaying of structures. The compound identifier is generated automatically by the server, and by default they are displayed in the order that they are returned. If the idea molecule matches a compound in our database, we display the compound name at the top. This is very useful as you know the compound has previously been made. Currently we have no sorting on this output. Expanding this drop-down menu, we can apply some simple sorting to the compounds. As you can see, we can sort on physical property calculations, and we recommend sorting on relative molecular mass. Once clicked on, the pagination display changes and shows the heaviest compound in the top left corner. The blue arrow here sets the direction of the sort, highest to lowest or lowest to highest. Sorting is fast, so it is easy to toggle between them. In our example, we ask for ideas that increase solubility and are monobasic, so we have been suggested neutral solubilizing groups as they do not change the charge. Here we can see some interesting examples. Generally, it is useful to start with the smallest compounds and work upwards. Usually, in medicinal chemistry, it's useful to reduce the mass, so why not work up the results this way? So the lowest mass compound is just a methyl group, replacing the entire chlorophenyl group. Yes, we would expect that to improve solubility. So, has this been made? Could it be made? What is the gain in solubility? And is it worth the changes to the other properties? These are questions we ask as medicinal chemists. Let's say I like the methyl compound. I can select the molecule by clicking the box at the top right of the cell. You will now see the Save Selection blue button activated. Let's click this cyclopropyl. Let's add the pyridines and click the second tab. We see some polar groups replacing the chloro, not a surprise that they will increase solubility. Of course, the computer will suggest things you already know. We designed our system to explore and capture all of the available knowledge. If we now click the Save Selection button, we can export just the compounds we have selected in a variety of formats. We can see it tells us how many compounds that we have selected. Details of the export options and settings will be covered in a different video. Just to remind you, if we click the Save button here, it will export all of the compounds in the run. So, we have looked through the results by sorting on relative molecular mass. What about using some of the matched molecular pair statistical data? If we go to the drop-down menu and scroll down a little further, we find options to look at solubility data. If we'd have chosen metabolism, this would be a different list of assays. In our case, the rules have come from 3 different solubility assays, and we can select one of these to explore the statistical data from the rules. So, by clicking the top solubility assay, we can look a little deeper. By default, the display changes to the counts of molecule pairs and a second drop-down menu appears. We find that chemists usually prefer one of 2 numbers, either the pair count we have here or the median change. For pair count, it's the total number of pairs that increase the property over the total number of pairs for that transformation. So, for this chloro addition, we have a minority of matched pairs that improve solubility compared to the pair count. It is unlikely to improve solubility. What we need in this case is to flip the sorting to pair counts where most of the pairs improve solubility. Click the blue arrow here to flip sorting. Now we see a pyridine suggestion, where the counts are in favour of increasing the property. Interestingly, the third compound in the list is this extended side chain of a hydroxy group, where we see 51 out of 75 matched pairs improving solubility. This is the AKT candidate drug. The other preferred view by chemists is sorting by median change. Let's click this one and look at the data. Now the sort pulls to the top the compound suggestions where the matched pairs had the largest median change. For this interesting neutral solubilizing group, the median change is over 1 log unit. Remember, we perform analysis on a log 10 scale. You can see the median change gets smaller as we run through the compounds. Remember, if we were looking at decreased metabolism, we would be looking for the largest negative number. So, there we have the rapid method of looking at results. We can see sensible compound suggestions with evidence to support synthesis. That concludes this short training video on rapid results viewing in RuleDesign. Please contact support@medchemica.com for further help.